So now that we know that the equilibrium constant, Kc is the concentration of the products times to the power of their coefficients, we can now start looking at what the Kc means and interpret that. So if Kc is very large, that must mean that relatively speaking the products are quite high and the reactants are quite low. So if the products are very high and reactants are very low, that must mean that this reaction has gone almost to completion. Okay, and likewise, if you have a Kc that is very small, so Kc is very small, that means relatively speaking the products are quite low and the reactants are quite high. Reactants are quite high, products are quite low. That must mean that the reaction has mostly stayed as reactants, and so there aren't many products. Okay, and so there we have the summaries there. So the summaries lies down here. So K very large products, K very small reactants. So you need to go through the process, the thinking process that I've just done for you just there. Would not try and memorize almost anything in chemistry. You really need to go through the process of how it works. And that'll help you with tricky questions too. Another side point here is you've noticed they've gone for the 3. So generally in chemistry, if it's a factor of 3 by a factor of 1,000, we can generally consider it that the thing that is out by 1,000 is probably not significant. So for your percent errors, if you have a 1% error, and then perhaps you have then 1,000% error on something else, that will be the significant one, or a 0.001% error. It's out by a factor of 3. You can write your assumptions that it's not significant, and therefore you can assume it'll have no effect on the final result. And we do that here for Kc's also, and so you can see that what's considered very small is a factor of 3 sig figs out, and what's considered large is also a factor of 3 sig figs. So just a practice question here. So the following reaction is here and the concentrations are given. So calculate and comment on the Kc. So Kc, just write out the Kc expression. So products over reactants. The products here is to the power of 2. It's a little mistake there because they're, reactants to the power of 2 because there's a 2 there. So just double check all your working each time. So put the 0.5 in, put the 0.02 in, and you get 1,250 is the Kc for this reaction. And comment on the Kc. So because the Kc is large, that means that there is a lot of this stuff, which means there's a lot of this stuff. And so reactants over products, products over reactants. And so the equilibrium is favoured on this side. So the equilibrium favours the right-hand side, the side of the products.